every day I sit through the boring lesson, not listening, working through my polynomial simplifications, too lazy to check my work over. Instead, I use an app called Photomath to do it for me. Photomath uses machine vision to recognize characters and equations and solves them in the app. And it does this through a neural network. And a neural network uses math and computer science to mimic the processes of a human brain. It is made up of things called neurons, divided into 3 layers: the hidden layer, the input layer, and the output layer. And so to get an intuitive understanding of how a neural network works, let's use it to decide whether or not you should go to a carnival. And let's say there are 3 things affecting your decision on whether or not you should go: food, rain, and cost. You would input these factors into the input layer of your neural network, and each neuron is assigned a number value. Next, each neuron from one layer is connected to the neuron from the next layer through number-weighted connections. To process information through this neural network, the number weight of the neuron and the number weight of the connection is multiplied together and passed through the hidden layer until you get to the output layer. And depending on what value you get on your output layer, you would either decide to go to the carnival or to not go to the carnival. Arbitrarily, let's say if you get an output of 0.5 or higher, you're going to go to the carnival. But if it's 0.5 or lower, you're not going to go to the carnival. And this same process, and throughout this whole process, the weights of the connections connecting neurons will continuously change and adjust to make your network more accurate. This is how a neural network learns. And the same process is true for the neural network I built that classifies handwritten digits. And while the neural network looks more like something like this, the concept is still the same. And so this is the network in code. This is the part of the network that actually that specifies what kind of network it's going to be, how many layers there are, and this is the part of the code that actually randomly selects the initial connections of each neuron. And this is the part of the code that adjusts the connections between neurons to let the network learn. And now let's get into what makes neural networks so interesting: its ability to learn. And so, as I said before, the initial connections between each neuron is randomly set. So the first few outputs will be a little bit inaccurate. And you can see this in this slide, which is the output of the neural network that I built. Each epoch is one round of the neural network trying to classify digits, and how many out of 10,000 digits it classified correctly. And you can see that from the first to the last, it keeps adjusting itself and learning to be more accurate. And you can see at its peak, it classified digits with a 95% accuracy. And so let's get into the nitty-gritty of how this neural network actually adjusts those weights to learn better. So because each connection is randomly set in the beginning, as I said before, you're going to have inaccurate initial outputs. And so we define something called a cost function, which measures how poorly your neural network is doing its job. Therefore, to let your network learn, you're going to try to minimize your cost function. So the smaller your cost function is, the more accurate your network is. And so to minimize the cost function, you use something called gradient descent. And while this might sound like a weird, complex term, all you need to know is that the gradient descent finds the minimum of a function. You can think about this as a ball rolling down a hill to land in a little valley, except the hill is the cost function graph, and the valley is the minimum of this cost function. And this is how a neural network learns. And you might notice that I keep saying learn in air quotations, because the more you think about this, the less it seems like a neural network is some crazy sci-fi creation that has a brain of its own, and the more it seems like just a complicated math equation. So it's pretty clear that neural networks play a key role in the subset of artificial intelligence called machine vision. And while Photomath only helps me with my homework, other applications of machine vision include diagnosing cancer with better accuracy than humans, or powering autonomous vehicles, or more ominously, China's use of machine vision to classify citizens inside surveillance cameras. And on a larger scale, it's clear that every single industry in the world is going to be impacted by artificial intelligence. One day, we'll wake up, read on the way to work through AI-powered autonomous vehicles, follow health plans and education plans specifically tailored to us with machine learning algorithms, and who knows, maybe we'll be constantly surveilled by machine vision cameras, but it's clear that we're going to live lives sewn together with artificial intelligence. This is what the future is going to look like, and we can help create it. Thank you.